In this video, we are going to discuss fitting of a parabola. In the series of videos on curve fitting, in my previous video, part 1, we have discussed how to fit a straight line y equals a plus bx by the method of least squares, in which we have also discussed the derivations of the normal equations given below, which are required for the calculation of curve fitting. In this video, we are going to see how to fit a parabola y equals a plus bx plus cx square when a set of values xi comma yi are given. The parabola must be close to the given points as much as possible, as shown in the figure. By using principle of least squares, we will derive normal equations by using the principle of least squares. Let us see how this is done. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. Suppose Pxi, yi is a given point and a line through P parallel to y-axis intersects the curve y equals a plus bx plus cx square in point Q, whose coordinates then will be xi comma a plus bxi plus cxi square. We have to find constants a, b and c such that distance mod pq is minimum. Distance pq will be y coordinate of point P yi minus y coordinate of point Q a minus bxi minus cxi square. According to the principle of least squares, mod pq is minimum when the square of this distance yi minus a minus bxi minus cxi square is minimum, and this must be true for all the points. This means we must have this distance s equals summation yi minus a minus bxi minus cxi square whole square is minimum. Now, according to maxima minima, the conditions for s to be minimum will be dou s by dou a equals 0, dou s by dou b equals 0, and dou s by dou c also equals 0. Dou s by dou a equals 0 gives summation 2 times yi minus a minus bxi minus cxi square into derivative of minus a with respect to a minus 1 equals 0. Cancelling minus 2, summation yi minus a minus bxi minus cxi square equals 0 gives summation yi equals, for summation a we write number of observations n into a plus b summation xi plus c summation xi square. We name this 1. Next, dou s by dou b equals 0 gives summation 2 times yi minus a minus bxi minus cxi square into derivative of minus bxi with respect to b minus xi equals 0. Cancelling minus 2, summation yi minus a etc. minus cxi square into xi equals 0. Multiplying by xi throughout and rewriting it again, this will be summation xi yi equals a summation xi plus b summation xi square plus c summation xi cube. We name this 2. And finally, dou s by dou c equals 0 gives summation 2 times yi minus a minus bxi minus cxi square into derivative of minus cxi square with respect to c minus xi square equals 0, cancelling minus 2 and multiplying by xi square throughout and rearranging the terms, we get summation xi square yi equals a summation xi square plus b summation xi cube plus c summation xi raised to 4. We name this 3. Now from 1, 2 and 3, by dropping the suffix I, we get the normal equations. Summation y equals na plus b summation x plus c summation x square. Summation xy equals a summation x plus b summation x square plus c summation x cube, and summation x square y equals a summation x square plus b summation x cube plus c summation x raised to 4 for fitting a parabola. Fit a second degree parabola to the following data. Values of x 0, 1, 2, 3 and 4. N is 5. Summation x is 10. Corresponding values of y 1, 1.8 etc. and 6.3. Summation y is 12.9. We need x square 0, 1 etc. and 16. Summation x square 30. We need x cube 0, 1 etc. and 64. Summation x cube is 100. We need x raised to 4 0, 1 etc. Summation x raised to 4 is 354. We need product xy 0, 1.8 etc. Summation xy is 37.1 and we need x square y 0, 1.8 etc. Summation x square y is 130.3. Putting these values from the table, we get three equations. 12.9 equals 5a plus 100b plus 30c. Number 1. 37.1 equals 10a plus 30b plus 100c. Number 2. 130.3 equals 30a plus 100b plus 354c. We name this 3. We have to solve these three equations by eliminating variables one by one. So to eliminate a, we have to multiply equation 1 by 2 and subtract it from equation 2. That gives, after subtraction, 10a gets cancelled and we get 11.3 equals 10b plus 40c. Here we got equation in two variables b and c. We name this 4. Next, we will multiply this equation 1 by 6 and subtract the result from equation 3. That gives, after subtraction, 30a gets cancelled and we get, which is also an equation in two variables b and c. We will name this 5. Now in order to eliminate b, we will multiply this equation 4 by 4 and subtract this result from 5, which will be, after subtraction, we get 7.7 equals 40b gets cancelled equals 14c. So c is 7.7 upon 14, 0.55. Putting this value of c in equation 4, we get 10b will be minus 10.7. So b will be minus 1.07. Now putting the values of b and c in equation 1, 5a will be 7.1 and a 1.42. Assuming equation of parabola to be y equals a plus bx plus cx square, the equation of parabola that best fits the given values will be y equals 1.42 minus 1.07x plus 0.55 x square. We will solve similar problem by deviation method, where the deviations are taken from the midpoint. First, we prepare the table from the given values of x and y as follows. Corresponding values of y, which we represent by capital Y. Next column is deviation from midpoint. X equals small x minus 2. Here 2 is the midpoint of values of x, whose values will be, we get summation capital X equals 0. Summation x square, summation capital X cube is also 0. Capital X raised to 4, summation capital X raised to 4 is 34. Since summation x and summation x cube is also 0, the normal equations reduce to summation y equals na plus b summation x square summation xy equals a summation x square summation x square y equals a summation x square plus c summation x raised to 4, because here summation x and summation x cube are each equal to 0. Now by putting the values from the table and calculating, we get p equals 0.6, c equals 0.14 and a 1.71. Assuming equation of the parabola to be y equals a plus b capital X plus c capital X square, and putting the values, now capital Y is small y, from here equals a plus b into capital X is x minus 2 plus c into x minus 2 square. Putting the values of a, b and c from here in here and simplifying, we get equation of the parabola of the best feet y equals 1.08 plus 0.03x plus 0.14x square. Here the number of observations are 5, an odd number. Suppose if the number of observations were even, say for example n equals 6, then the midpoint would be average of this 2 and 3, which would be 0.5, and capital X would change to x minus 2.5. So these small changes need to be considered, and it should be noted that the calculations get reduced because here summation x and summation x cube become 0. Viewers, if you like this video, please click the like button. Share this video with your friends and classmates. Subscribe to this channel. Post your constructive comments to make the videos better. You can even check playlist of this channel. Perhaps you might find videos that you are looking for. See you in the next video. Until then, keep watching Number Collage. Thank you.